Hi and welcome to IPM Leap. Today's video is based on a grid wherein you have to count the number of possible routes if you move along the grid lines. These grid-based problems belong to the topic Permutations and Combinations and are frequently asked in various exams such as CAT, IPMAT, among others. And let me tell you right at the beginning that if you are facing such a question for the first time, it may seem difficult to you. But once you have learned the concept behind it, it becomes really simple and straightforward. So let's have a look at the question on your screen. There is a 7x6 grid given to you, which is like a road map. A person has to move along grid lines from point A to point B, taking the shortest possible route and stopping at points P and R, which are the bakery and milk booth respectively, to pick up a few items on his route. So how many different routes do you think exist? Well, just to give you some more idea, let me draw some possible routes for you. So this red and black line is one possible route. This rainbow line could have been another. But see, in this route, there is a downward turn, which means you are technically coming back and going away from B. In any shortest route, you can't take a back step. So movement is possible only in the right direction and upward direction, okay? This green line that you see moving on your screen is another possible route. You'll be surprised to know that there are hundreds of routes. We simply can't count them this way by drawing out each route. So how do we solve such a question? Let's discuss the concept. Okay, so first let's solve a simpler version of this problem. How many routes from A to B with no stops in between? Now remember, in permutations and combinations, whenever we need to count something, like the number of routes in this case, we should try to find something that is common to all routes. That will help us with the counting logic. In this case, if you look at the points A and B, I can safely say that in any route from A to B, a person necessarily covers this much horizontal distance and this much vertical distance. So if I break up the total route into small steps and consider this side of the small square as 1 unit or 1 step of the journey, then in any route from A to B, there are exactly 13 steps comprising of 7 horizontal units and 6 vertical units. Let us say the letter H denotes a horizontal step and the letter V denotes a vertical step. 7H and 6V complete the route. So for example, if I take this particular arrangement of these 13 letters, it spells out one possible route. All horizontal steps followed by all vertical steps. If I rearrange these letters, it would denote another possible route. See for yourself. H, V, V, H, 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 V, H, 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 V, V, V. The golden route is completed. One more rearrangement of these 13 letters would mean another possible route. V, V, H, V, H, V, H, H, V, H, H, V, H denotes the route that is being drawn on your screen. So hope the logic is clear now. Each arrangement of these letters denotes one possible route and therefore number of routes is equal to number of ways these 13 letters can be arranged. Out of the 13 letters, 7 are of one type and rest 6 of another type. So they can be permuted in 7 plus 6 factorial upon 7 factorial 6 factorial ways. This is equal to 13C6, which calculates to the value of 1760. If you want to revise how to calculate these combinatorial coefficients, you may watch our other videos on permutations and combinations, basics that are there on our channel. So let us summarize. In general, if we have any m cross n grid, the number of ways To traverse the grid from one end to a diagonally opposite end is given by m plus n factorial over m factorial into n factorial. Moving on, let's increase the complexity of this question and let's put two stops on the route. So this person, he needs to pick up a few items from the bakery and the milk booth stationed at P and R respectively on the map. How many different paths exist from A to B if he makes these two stops at points P and R? Not to worry, we can break down the total journey into three parts. First, this person moves from A to P. So we will separately count the number of routes from A to P. And then he moves from P to R. And finally, from R to B. So A to P, how many routes? There are two horizontal steps and two vertical steps. These letters can be arranged in 4 factorial upon 2 factorial 2 factorial. That is 4C2, 6 ways. So there will be 6 routes from A to P, as each arrangement of these 4 letters spells out one possible route. From P to R, there are 2 horizontal steps and 2 vertical steps. Number of routes will be 6. And finally, from R to B, there are 3 horizontal steps and 2 vertical steps. Number of routes will be 5 factorial upon 3 factorial 2 factorial. That is 5C2, which is equal to 10. Therefore, by using the fundamental rule of counting, total number of routes from A to B via P and R are equal to 6, which is the number of routes from A to P, into 6, which is the number of routes from P to R, into 10, which is the number of routes we calculated from R to B. This number is equal to 360. 360 possible routes from A to B via P and R. Now let's consider a variation to the same problem where there is a shortcut on the route which the person will necessarily take to shorten his route. So as you can see on the screen, there is an open space midway with a diagonal path across it. This problem is very similar to case 2, so I will use the same calculations. The total route has 3 paths, A to P, P to R via the shortcut, and R to B. Number of routes from A to P are equal to 6. Number of routes from P to R is equal to 1, only the diagonal one. Number of routes from R to B are equal to 10. Therefore, total number of routes using the fundamental rule of counting will be 6 into 1 into 10, that is 60. And our final case, it's a little complicated, so pay attention. On the way, there is a forbidden area that the person is not allowed to enter. Then how many routes are possible? Our strategy to solve this question will be to count the total number of routes from A to B that don't pass through the point T. A very simple way to do this is to count number of routes from A to B, which we have already done in case 1, and subtract from this the number of routes from A to B via point T. Because all routes through the forbidden area will necessarily pass through point T, right? So how many total routes from A to B via point T? Count separately the number of routes from A to T. 3 horizontal and 3 vertical steps. Number of routes will be 6 factorial upon 3 factorial 3 factorial. That is 6C3, which is equal to 20 routes. Similarly, let's count the number of routes from T to B. 4 horizontal steps and 3 vertical steps. Number of routes will be 7 factorial upon 4 factorial into 3 factorial. That is 7C4, which is equal to 35 routes. Therefore, the total number of routes from A to B via point T will be 20 into 35, 700. And we have again used the fundamental rule of counting here. So we need to calculate the total number of roots from A to B that don't pass through the point T, which will be equal to 1716 minus 700. So 1016 roots that don't pass through the forbidden area. So hope you enjoyed this lesson. Don't forget to press the like button and subscribe our channel for similar videos, all of which are immensely useful for your exam preparation. Here is a sneak peek into our next video from the topic probability. For now, take care everyone and all the best for a super duper career ahead. Bye bye.